In the monkey, the first visual area is on the outside. It's on the lateral surface. It's all nicely stretched out so you can see this picture-like quality. In humans, it's in the middle and it's folded, oddly. So the way to think about it is when something is right in the center, the fovea, it's going to activate the center of this representation, which is at the back of the brain, the way the thing is folded around. As it gets larger, the activation goes forward. So you have, this brain doesn't have it, you have something called a calcarine fissure. Okay, if you open this up, you'd see this thing going like that. The very back part is where the fovea projects. And then as it gets increasingly further out towards the periphery, you get activation increasingly forward. That's just the way it works in humans. So what we did is we did a series of experiments. One of them, we asked people to study some pictures. Things like an anchor that is tilted slightly. And they didn't know we were going to ask them about the pictures later. But, okay, they studied the pictures. And then later on, we asked them to visualize them and answer a question, like is the right part higher than the left part, which they can only get right if they use that image. An anchor in general won't answer that. And the trick was we had them study before each run, each test in the PET scanner, a box which was either very tiny, medium, or very large. And they were asked to visualize each object at only that size while we recorded their brain activity. So we had 3 sizes, and we varied the size, and we had them forming the images and answering questions about them, and we monitored their brain activity at the same time. And what we found was when they visualized it very tiny, the activation was at the very back of the brain, just like you find in vision. When they visualized it, and their eyes are closed now, medium size, it moved forward, and if it visualized it large, you moved even further forward. So this was very good evidence that mental imagery is not only making use of parts of the brain that are involved in vision, including the first visual area, somewhat to our amazement, but also can affect processing in that area in a systematic way.